Hello students, welcome to SOURAV Sir's classes. Today we are going to solve a few questions on real analysis. The question is, which of the following subsets are compact? Option A, mod x less than equal to 1, mod y greater than is equal to 2. Option B, mod x less than equal to 1, mod y squared less than equal to 2. Option C, x squared plus 3y cubed less than equal to 5, and option D, x squared less than equal to y squared plus 5. Now, we know that for a set to be compact, it must be closed and bounded. Thus, if a set is closed and bounded, then it is compact. So, now for option A, this is not compact as it is clearly unbounded. Since mod of y greater than is equal to, this is unbounded. Now option B, this is closed and bounded both. Thus it is compact. Option C, this set is filled ellipse and its boundary having length of major axis root 5 and that of minor axis root 5 by 3, which is closed as well as bounded. Thus, this is also compact. And option D, this is clearly unbounded, as say when x tends to infinity, y also tends to infinity. Thus, it is not compact. So only B and C are compact. Therefore, B, C are the correct options. The next question is, which of the following are metric spaces? Now option A, DFG is equal to 0 if and only if supremum mod fx minus gx such that x belongs to 0, 1 is equal to 0. If mod fx minus gx is equal to 0 for all x, if and only if f is equal to g. Also, dfg is equal to d of gf, and for this, that is for option A, the triangular inequality is also satisfied. Thus, it is a metric space. So, option A is correct. Now, option B, take fx is equal to x and gx is equal to 1 minus x. Now note that f of half is equal to g of half. So, infimum mod fx minus gx such that x belonging to 0, 1 is equal to 0, but clearly f not equal to g, thus it is not a metric space. Now for option C, since mod of fx minus gx greater than is equal to 0, we have integral 0 means mod of fx minus gx is equal to 0. That is, fx is equal to gx for all x, and D is also symmetric and satisfies triangular inequality. Thus it is a metric space. Now for option D, option D is the sum of matrices, or rather sum of matrix. I'm extremely sorry for using the word matrices. This is the sum of matrix given in option A and C, and sum of two matrix is again a metric. Thus option D is also correct. So A, C and D are the correct options.